right now, and I usually record the lessons and then I post the video. Okay, and I'm still going to continue to do that, but I am also going to leave the Pear Deck link there as well. So you'll have two things that you can go back and look at. So you can look at the original Pear Deck, which is going to switch over to student pace at a certain point, and then you'll also have a video recording of what we talked about together. All right, so we're talking about translations today, which is a type of transformation. It's when you take geometric figures and you move them around the coordinate plane. We're going to talk about translations. We're going to talk about reflections, rotations, and today we're starting with translations, though, which is basically a slide, if you remember that. Okay, so your EQ is up here. How do you draw the image of a figure under a translation? So that's what we're looking at, how we're going to do that today. And then you also have 3 I can statements. So at the end of this lesson, these are 3 things that you should be able to do. I can draw the image of a translation given a pre-image and the description of the transformation. So when you have a transformation you're doing, we call the pre-image is what you are given, and then the image is what you have after the transformation. I can create the image of a figure given a rule and the pre-image. All right, so the pre-image is what you start with. The rule is describing the translation that you're going to be doing today. And I can. I have I can twice. Okay, I gotta take that off. Generate a rule in coordinate notation that describes the transformation of a pre-image to its image. So we're going to look at notation for the coordinates, the x and y coordinates. How do the x coordinates change? How do the y coordinates change depending on how you are translating your image, how you're sliding it from left to right, up and down over the coordinate plane. So this is some vocabulary that's useful for today. We have vector, and it's a quantity that has both direction and magnitude. There's a picture of a vector right there. That's the vector v, or it can also be called vector EF when you refer to the 2 endpoints, the initial point and the terminal point. Okay, the initial point is the starting point of the vector, and the terminal point is the ending point of a vector. A transformation, so this whole unit is about transformations. A change in the position, size, or shape of a figure. A transformation maps the pre-image to the image. And then the type of transformation we're looking at today is the translation. And those 2 words are pretty similar because they both start with the T-R-A-N-S, but they're different words. Translation, a transformation in which all the points of a figure move the same distance in the same direction. The figure is moved along a vector so that all of the segments joining a point and its image are congruent and parallel. All right? So this is just some imagery to kind of help you understand translations. So one thing that I've always mentioned to math students when learning about translations to remember which one it is if you think about the word, so here in red I have the word translation and I have the word slide. And notice that I've highlighted S and L in both words because it's just a little memory trick to help you remember which one translation is. Okay, so if you think of translation, you're actually sliding an image left to right or up and down. And then so we have some examples here. So translate 2 units right and 4 units up. So the object that we're starting with, each of the vertices is moving 2 units to the right and then 4 units up. And notice if you go to all 3 vertices, that same thing is happening. It's going 2 to the right, 4 up, 2 to the right, 4 up, 2 to the right, 4 up. And then it creates the same exact image. It doesn't change size or shape. So that's one example of a translation. Here's another example of a translation. Sometimes the vertices will be given letter names like A, B, C. And then after the translation, they turn into A prime, B prime, C prime. So that's something you see. This is a translation of just 6 units to the right. So you don't have to go left, right, up, down. Like you don't have to have multiple things happening. It could be just one movement, like to the right. And then here's again using the word slide, so you can see the pre-image turns into the image because it's literally sliding. All right, so these are the coordinate notation rules. So when we translate a units to the right, if you think about that in the coordinate plane, when you're moving to the right in the coordinate plane, your x-coordinate is increasing. So however many units we move, we add that number to x. If we move to the left, then your x-coordinate is decreasing. So we would subtract that many units from x. If we translate a point up, well, your y-coordinate is then increasing. So that's why we're adding that many units we translate up to the y-coordinate. Whereas if you're translating down, your y-coordinate is decreasing, getting smaller, so we subtract that many units from the y-coordinate. And notice that these aren't parentheses, okay? This is a different notation. So this is referring to a vector. It's a special type of notation for translations, okay? For transformations. It's like a pointy parenthesis. All right, so at this point now, what I'm going to do for you, and this is new, is I'm going to turn it on to student paced, okay? And the rest of these slides, you're going to go through. You're going to watch a small video or look at it as a small example, and then you're going to try one on your own. So I'm still here to help you. You can come into the chat and ask questions. You could come onto our GoGuardian and ask questions. You could come off your mic and ask questions. But right now, you're going to move into your own pace with this Pear Deck slide. All right, so that's what we're going to be working on until the end of class, which is 10 o'clock. So you have 35 minutes to go at your own pace and finish this. And if I see we're getting stuck, I'm watching you guys as you're entering your answers, okay, because I have my teacher version, so I can see how you're answering things. But start by watching the video. If there's a video, you need to watch it. And you did a really good job participating and trying these different slides. But because I'm turning it back on teacher paced for a moment, just to review with you the ones that you did together. I mean, you did on your own, so you can see what the answers are together. And then I'll put it back on student paced after that, and then you'll be able to still access this Pear Deck presentation. And then I will also post a video, so you have 2 different resources for the same lesson. So let me come back to right here, representing this. Okay, so draw a translation. What did you guys come up with for that point? So 5 units to right and 7 down. 1, 2, 3, 4, almost. Right here. Let's see, 1, 2, 3, 4, 5 to the right, and then 7 down. So this is exactly what you want for slide 6. And if you had like the mark showing where you were going, that's totally fine. Okay, but this is the pre-image, and then this is the image after the translation. And then we take a look at 8. Oh, very, very nice. Proud of you. Look at that. You all got it right that tried it. I am very impressed. Nice work, you guys. That is definitely 6 to right and 3 down. And so if you're trying to figure it out, the pre-image is the blue one, the red one is the image. Just take any specific point, maybe G, and then you would just count over and down, okay? So that's where the 6 to the right, 3 down came from. Now, if you wanted to write that into a notation, okay, this is using that vector notation now, how do you show 6 to the right and 3 down? No. Yes. 6, -3. 6, -3. That's exactly what you want. 6 and -3, because this means you move to the right because it's a positive 6, and this means you go down because it's -3. Awesome. All right, and then the last slide we want to go over was slide 12. So it says create the image. These are your pre-image coordinates. You would have to plot them on this little graph here. And then this is your vector, -2, 3. So this is what we're doing. The x coordinate is changing because it's going to go down 2, and the y coordinate is changing. It's going to go I'm sorry, scratch that. The x coordinate is changing. It's going to go to the left 2, and then the y coordinate is changing because it's going to go up by 3. All right, so let me just show you. This is what you should have got. And if I'm looking through your answers, I know it's a little bit tricky the way they kind of in the gray box had you put in those values, but notice that the minus sign is already there, so you would just put the 2. If you put -2, I can see how you might get confused. This person did a really good job though. Juliana, you did a really nice job. So I'm gonna share Juliana's work because she did a nice job with almost everything. I know this was a little bit tricky because of the minus sign here, and then this is a -2. So yeah, you do use -2, but because the minus is there, this should just be +2. So if I cover it up like that, it's perfect. But good job drawing your triangles. Okay, that was great. So anyhow, that is the end of our presentation. I'm going to turn this back into student paste. All right, so now you can go back into this and play around with it anytime you want. It's available to you. I'm going to post a video of what we did today. So if I come back to our week at a glance, let me go find it and show you where it'll be.